Thank you for joining our webinar. This topic is load balance route policy. This is our outline. First, I'll tell you why we modify load balance route policy. And then what are new? I will explain each features one by one. And who will be involved. When you upgrade from the previous firmware, you will see the difference. How it works, the idea of priority, and the usage in real world. And our future plans. We still have some future plans to make it even better features. So I'll tell you our future plans. Also, I'll have live demo. I'll demonstrate 5 different features on how to use route policy. And the troubleshooting. We have the new troubleshooting tool. So why we modify route policy? In the past, our load balance route policy overrode interLAN routing. Imagine you have dual WAN, LAN 1 for your servers, and you have LAN 2 for your LAN clients, the PCs. So we create 2 policies for load balance. The first rule says when LAN 1 go to any destinations, send through WAN 1. And the second policy says when LAN 2 go to any destinations, go through WAN 2. So it's a very basic load balance scenario. But what if your LAN 2 clients want to access the servers in LAN 1? Since we have this policy says when LAN 2 clients go to any places, the traffic should be sent through WAN 2. So we were not able to access the LAN 1 server. In order to access the servers in LAN 1, we need to create another route policy for this interLAN routing scenario. So you need to move down the policies and create the first policy says when LAN 2 go to LAN 1, send through LAN 1. It will work. But what if we have more than one subnet? It will become more troubles. You have to create so many rules for your interLAN routing purpose. That's why we have this wish from many distributors. That says people hope they can decide the priority between routing table and route policy. So that's why we modify the route policy. Not just for priorities, we also put in many different features. So let's compare one by one. This is previous version, and this is the new version. So let's compare. First, we support the same protocols, TCP, UDP, and ICMP protocol. And about the source IPs, we support IP subnet here. In the past, you have to type the IP range, and in the new version, we support IP subnet. We have predefined subnet for you. And the interface, we have split WAN LAN and VPN to different drop-down menu here. Also, we support VPN trunk. If you choose VPN, you choose the VPN trunk member, then we will send the traffic to the VPN trunk. I will show you this in the demo. And force and native force routing, it's like the previous firmware. And failover. In the last version, we only support failover to other WAN, to the default WAN. But in this version, we have more flexible failover. You can fail over to the default WAN or certain WAN interface. Also, you can choose the gateway. But if you choose default WAN, it makes sure the router will choose the WAN for you. This is for WAN and LAN. And you can also fail over to VPN tunnels and to another route policies. So we have 50 route policy index. Imagine you can achieve 50 layers of failover. And there are 2 versions of failback. The first one is immediate failback. If you click the failback button, the router will clear all the sessions affected by this policy immediately when the original interface resumes service. I'll demo this part later. And also the gradual failback, so just don't click it. The new sessions affected by this policy will be sent through the original interface. And the existing sessions will still remain on the failover interface. I'll demo this part later so you can have more clear view. The last one, the priority. Now you can configure your priority for each policy. If you drag to the right side, you can set the priority higher. If you drag to the left side, you have lower priority. So this is the previous route policy general view. In the new version, we put priority in, so you can compare the priority for each policy. So if you drag to the left, the general view will show the priority for you as well. So this is the general view. This is the previous version. You don't see the priority there. And this is the new version. We put in priority. And also we give you a drop-down menu to show more policies. You can choose how many rules you want to show per page, and then we'll show you. So you can compare different policies. So the first one is 2925 in the firmware 376, and 2860, 2760, and 2912. So these four DrayOS models, they will have the new route policy. So this is the previous version. When you do firmware upgrade, the router will detect you have some old policies. Once you upgrade to the new firmware and you come to this route policy page, you see there are some notification on the upper side. So let's take a look at what we said. We say first one, we explain why we made this modification. That's because the route policy always has a higher priority than internet routing. This firmware, we make the priority configurable, and we detect that you have old policies inherited from the previous firmware. In order to let you know the difference, we put these notifications, and you have to click the Upgrade All button to start configuring the new policies or to change the old policy. We list out the main differences between the previous firmware and this firmware. So in the previous version, the VPN has highest priority, and the routes in the routing table, they have lower priority than route policy. That's why the route policy can override the internet routing. In this version, the VPN now has the same priority as routes in the routing table. So when you create the new policy, you decide the priority for your policy. So if set it have higher priority, it may still override internet routing. So that's the notification we sent to the users. If they don't click the upgrade all here, they try to get into the policy. You can see that we don't have the OK button. We only show the upgrade all button or cancel. So still they need to put the upgrade all button there. So once they click the upgrade all, they will be able to configure or to create a new policy. Once they click the upgrade all, we show the ordinary general view here. You can tell this is a new version because we show the priority in the middle. This is a difference of general view between the previous version and this version. And now I'll explain the idea of priority. First, we compare between the routing table and route policies. So imagine we create a policy and give it a priority as 100. Please note that the smaller the number, the higher the priority. So we give it 100. So I make a note here. Also, this is the routing table. So if we take this example, we have two subnets and two WANs. We are trying to get to LAN 1 from LAN 2. So we need to compare. The first is the routes in the routing table. That's right here, the LAN 2. This route has priority as 150. And then we have the policy has priority as 100. We compare these two. The policy with priority as 100 has higher priority, so we choose this one. So still we send the traffic to WAN 2. But if we modify this policy, we give it 200 instead of 100. So let's compare again. This time, the route in routing table has higher priority. So now we can send the traffic to LAN 1. With priority as 200, you don't need additional policies for internet routing anymore. So this is the idea of comparing between routing table and route policies. So let's take another example. Says from LAN 2 to 8888, we give the priority as 200 here. This time, the route we compare is the default route, since 8888 doesn't belong to any LAN subnet or VPN subnet. So that's on the internet. The default right here. By default, the default route is the WAN1. So now we compare the WAN1 or the policy. The WAN1 default route has priority as 250, and the policy has priority as 200. This time the 200 is higher, so we'll send to WAN2 instead of the default route as WAN1. So this is the idea of comparing between routing table and route policies. The priority first, sequence second. In the past, we only compare the sequence with respect the first policy, but in this version, we check the priority first. So imagine here, if I want to go to 8888, there are three policies matched: index 1, and also index 8, and index 10. So which policy will be chosen? Since index 8 has priority as 137, the router will choose this one and send the traffic to WAN1. So this is the idea of priority first. But if we disable this policy, so in this case, the router will choose index 1 instead of index 10, since index 1 is the first policy we matched. So let me emphasize again. First, we check the priority, and if there are more than one policies having the same priority, we check the sequence. So how people use load balance route policy in real world? First, they do basic load balance, and they can do address mapping, force NAT, force routing, and route policy with VPN tunnel. You can route local users to a VPN tunnel, or you can route remote dialing clients to your WAN. First one, load balance. Imagine you have two WAN, WAN1 and WAN2. Maybe your WAN1 has less jitter, so you want to send your SIP traffic to WAN1 instead of WAN2. So maybe you can set like this, destination port 5060, send through WAN1. So this is the basic load balance. About address mapping, if your ISP gives you more one IP address, you can choose your IP here. I'll demo this part later. And also force NAT force routing. Imagine you have two WAN. One is NAT WAN and the other one is routing WAN. You have LAN 1 for your PC here. You have LAN 2 for your IP phones. Just for example, you want your traffic from your LAN 1 clients go through WAN 1 and do NAT. And you want your VoIP to public server go through WAN 1 and also do NAT. The public server could be, for example, IPTel. At the same time, you want your VoIP to ISP server or your private server send through WAN 2 or WAN 5, and you want it to be routed. With route policy, we can achieve this. Route policy with VPN. You can route your local user to a remote server. For example, your PC or your IPTV want to watch Netflix, but Netflix only accepts IP address within the States. In Asia, we are not able to watch Netflix. So what to do? You can send through the VPN tunnel. The VPN server is in the States, so the traffic will send through the VPN tunnel, and then you can watch the Netflix. Maybe you can create a rule like this one. Let's take a look here. Set the destination IP address as the Netflix server and choose the interface as the VPN tunnel. It will work. Also, you can route remote dialing clients to the WAN. For example, these remote dialing clients wants to go to Facebook. Like in China, the Facebook is blocked. Maybe you're on a business trip to China and you dial the VPN tunnel to home and route the traffic through your home router to Facebook server, then it will work. So it's the same. Choose your source IP address as your remote dialing client and choose the interface as the WAN. It works. So I'll have more detailed explanation in the demo. Now I talk about the future plans. Support hostname in route policy. Also, we will support wildcard. So in the future route policy, you can just type, for example, google.com, send through Win1. So the router will check all the traffic, and what if you are going to, for example, www.google.com, will send to Win1. Or you want to go to mail.google.com, will send to Win1 as well. So this is the supporting hostname and wildcard. Second, we want to add a comment field. So you can have some comment for each policy, so you won't forget what's the purpose for this policy. Also, we will support path failure detection for failover failback. Right now, our failover is based on the WAN failure. If your WAN is down, and we failover to another WAN. Our Turkish partner, they want these failure detections. So that means even though our WAN is not down, and we can actually go to maybe Google and other ordinary browsing, but we cannot access our destination server, for example, your PBX on the internet. Now we only need to fail over to another WAN and we can access. But that doesn't mean our WAN1 is down. It's just a path failure. So we can still keep using WAN1 for other usage, and we only fail over this policy to the second WAN. So this is the idea of path failure detection. We will use pin. We'll give a column. You can enter the pin IP address. Could be your, for example, your PBX server. So use pin to detect. If the pin failed, we will do failover. And of course, we will support failback as well. So this is the idea of path failure detection. Also, we will support batch diagnose tool. Now we support single diagnose tool, and I'll show you later in the demo part, so you will have more clear view about batch diagnose tool. Now I'll demo. First, I'll change between priorities and show you the difference. And I'll demo address mapping, force native, force routing, route policy with VPN trunk, failover, failback. So these are the 5 demo I will do. So let me introduce my router here. I have dual WAN. This is my WAN1's IP address, and this is my WAN2 IP address. Also, I have 2 LAN. The first one is 100 subnet. Second LAN is 200 subnet. And I have one VPN trunk, a low bands, VPN trunk, low bands. And remote subnet is 85 subnet. So first, I'll demo the priority. So I create 3. Now I enable 3 policies here. The first one is from any subnet, from any LAN clients to 8888 go to WAN1. And also I have, so let me do the trace route here. So right now if I do trace route, we can see that we are using WAN1. So here you can see the gateway is the WAN1 gateway. Let me show you again. The WAN1 is 241.1, and the WAN2 gateway is 1.1.1.1. So again, right now they all have the same priority as 200. So the first one hit, first one get. So we send the traffic through WAN1. But if I create another policy here, this time I send to WAN2, has higher priority. So transfer again. So this time the gateway is WAN2. So this is the idea of priority. Also, I want to show you I'm on LAN 1 right now. I can pin my LAN 2 PC. But if I increase the priority to override the internet routing here, this policy says from any to any send to WAN1. So let me pin again. This time I cannot access the LAN2 clients. So the policy is override interLAN routing. So if you want interLAN routing, all I need to do is put the policy back just lower than 150. So this time I can access the LAN2 subnet again. So this is the idea of changing between priority. Second, I'll do the address mapping. Maybe imagine your ISP give you more than one public IP address. So you click here, the WAN IP alias, and type your IP here. Close, and go back to your policy. You can see I have three selections here. The 100 is my WAN one right now. Maybe I can choose 100.1. So how to verify? To verify this, we can use Wireshark. Just to let you know, I have enabled LAN port mirror to capture the WAN packets. So right now I'm using Wireshark to capture the WAN packets. So right now, if I go to 8888, this policy index number 6 will be adopted. If I pin, right now we are showing the IP address as 1.1.100.1. That's because we choose the IP alias. Let me change the other IP address again to 100.102. So you can see right now we are using 102. So this is the idea of address mapping. So now we do force NAT force routing. For example, I enable this policy here on index number 2. When I go to 8844, I can choose force routing. So when I do pin 8888, I got netted. But if I pin 8844 right here, you can see right now I don't have any response because I got routed, and that's the reason I don't get any feedback because the internet doesn't recognize my private IP address. But at the same time, if I pin 8888, I still got netted. So it's a very flexible feature. You can do netted or routed according to the destination IP address at the same time. So the route policy working with VPN trunk, I create a policy here, index number 3. I say when I go to this IP address, this is a DNS server in our country, send through VPN1. The VPN1 and VPN2 consist the VPN load balance trunk. Let me show you again. Here, the VPN1 and VPN2. They are the VPN trunk member. So I say when I go to this IP address, send through the VPN trunk. So how to verify we are actually sent through the VPN trunk? Let me pin first. There are a few ways to verify. The first one is come here and check the you can see we are now sending traffic to both tunnels. This is one way to verify. But also I have more precise way to verify. This is the console log we have on the router, and when I pin, it prints out which policy we are using. Let me stop right here. So when I pin, it says it match the policy number 2. We start from 0 because it's a binary number. 0 is number 1. So number 2 is index 3 here. So it shows that we are using index number 3. If I go back to 8888 again, you can see we are now using number 5. This is an explanation about console log. So let me keep going. If I pin this server, this IP address, you can know this part. Interface number 10. This is the VPN 1, and interface 11, that's VPN 2. So you can see we send 10 packets to VPN 1 and then another 10 packets to VPN 2 to do the VPN load balance. So you can see now we go back to 10 again. And after 10 packets, we send to VPN 2 again. So you can imagine we have 1 packet per second right now. If we have like 100 packets per second, the load balance will be very powerful, because we will send 10 packets first to tunnel 1 and another 10 packets to tunnel 2, and we switch in between just to share the loading between the 2 tunnels. So this is the idea of VPN trunk. All you need to do is get inside and choose the VPN trunk member, either one, and this raw policy will work with VPN trunk. So this is the VPN trunk part. Now this is fun part here. Raw policy failover failback. I have the FTP server inside this subnet. So I say when I go to the FTP server, go to WAN2, and also when WAN2 down, failover to WAN1. And let me demonstrate first. So here, this is my FileZilla. Let me log in. So let me download a very big file here. So now I start download. I can go to data flow monitor to make sure the traffic, you can see here, they all follow the rules, says go to WAN2. So now we can see many sessions here. And let me go back to the rule again. As you can see here, I have enabled failover to WAN1. So now, data flow monitor here, let me unplug WAN2, the WAN I'm using. So you can see the download is freezed. And very soon the router will detect WAN2 is down. You can see we have now failover to WAN1. So this is the failover. So now WAN2 is down. So even though I put back WAN2, since I didn't enable failback, the download just keep going. So now you can see the WAN2 is now back, but the download is still using WAN1 because I didn't click the failback. So the router will let the session keep going through the failover interface. But what happens if I come here and click failback? You can see the download freeze again. And then very soon we will use the WAN2 to download. Now we need to wait for the TCP timeout on the VPN client. So you can see now the FTP client login again through WAN2. So now the traffic all goes through WAN2. Right now, I'm not still satisfied about the failover because every time the WAN's back, my FTP download will be stopped, and I need to restart again. That's because we set the destination as IP address. So the better way is to try to set as port. So let's run again. For example, I said the port 21 go to WAN2. So if my WAN2 down, they'll fail over to WAN1. But you know the FTP download port is not 21. The 21 is only for registration. It's not for download. So when my WAN2 back, I can still keep downloading through WAN1 because the router will only clear the related stations, and the download station is not related to these policies. even though my WAN 2 back, I can still keep downloading on WAN 1 without being stopped. This is very helpful for the VIP traffics because we only use 5060 for registration. For example, you can create your rule like here. So you can say I want the SIP traffic sent through WAN 2, so you send out the first registration from your WAN 2, and now you make a call. So we send the traffic through WAN 2 right now. And once your WAN 2 is down, you can dial again through WAN 1. But what happens if your WAN 2 comes back? And you can still keep talking on WAN 1 because we only fail back your 5060 traffic. So the next call, when you make the next call, you will go back to the WAN 2 because if you register again. Since I cannot share with you my VoIP call, so let me demonstrate with FTP right now. So, okay, let's log in again. So again, I'll download big file. You can see right now I'm downloading from WAN 2. So now I've unplugged my WAN 2 here. Just take a few seconds to wait for the timeout. And the FTP client will download again from WAN 1. So right now I'm using WAN 1 here. So even though I put back my WAN 2, you can see WAN 2 is back because we start to have sessions. I'm still downloading through WAN 1. So it's a huge difference between if I type IP address here and enable failback, I'll get disconnected once the original interface comes back. But if I use port, I can still keep downloading through the failover interface until I start the next sessions. So this is the totally different scenario. Let me show you again. Put back. This is my IP address. So you can see once I enable these policies and enable failback, I got freezed. The client will download again through the preferred interface, which is WAN 2. You can see now I'm using WAN 2 here. So make your policies more flexible. Choose IP address or port according to your real usage, and then you can have a very flexible outcome. This is the demo part, and now I want to show you the diagnose tool here. So this is my IP address .10, and I can type if I want to go to 8888, which policy will be adopted. The left side shows the route in the routing table, and the right side shows the policies. So it says, okay, now I match the route policy number 5. So this one has higher priority as 200. That's why the packet was sent through WAN 1 according to policy 5. In policy 5, we says WAN 1. So let me enable this rule again and do a diagnose again. So analyze. This time we use index 6 because it has much higher priority, 176. And I'll send to the WAN IP address 3 according to policy 6. If you click number 6 here, you can see I'm using the WAN IP alias number 3. So this is the diagnose tool we will have. Also, each time you are creating the policies, we also give you the diagnose. So if you create policy, go to 8888 and click diagnose. We show you all the matched route policy. You can see each of them. If you want to modify, you just click here. Maybe like this one, just click here and make it higher priority. And do the diagnose again. So you see now we are using number 5. About the interlane routing as well, let's put this as higher priority. So let's check the interlane routing. I want to go to lane 2. As you can see, this match route in the routing table is lane 2, priority is 150. And we choose this one because it has higher priority here, policy 5. So maybe I come back and put it back to 200. Okay, and diagnose again to lane 2. So analyze. So this time was sent to lane 2 according to the routes in the routing table. So this is the diagnose tool. This diagnose tool is not finished yet. You can see we only support source IP address and destination IP address. We don't support protocol here and the port. So in the future, we will make it support protocol, source IP, destination IP, and port. So you can type the same criteria and do the analyze. So in the future also we can support the batch diagnose. So upload the CSV file with the format, source IP, destination IP, and destination port. Then we'll print out all the results for each query. Okay, so this is the whole idea of demo and diagnose.